What up, mathletes? Awesome. This is our first lesson out of the actual book. What? I know it's on virtual, but you know what I mean. It's still out of the Math 2 book. We've got you worked up some back skills. We're going to start like crushing it. So here is the warm-up. We'll start most days with the warm-up. Visually determine the points that lie midway between each pair of points. In other words, find the midpoint visually and just mark it down in your notes. Ready, set, go. Okay. I'm assuming you paused me, came back. So if I'm looking at A and B, it looks like this is right in the middle, right? Let me get my writing utensils out. I think right here is in the middle. And that is the point 1, 2, 3, 1, 2, 3. So that is 3, 3. C and D. That looks like it's right in the middle right there, just looking at it. Which, yeah, 1, 2, 3, 1, 2, 3. There we go. So it's going to be -2, up 2. -2, up 2 is the coordinate. EF, this looks like it's in the middle right here. And that is the point, -2, -1, 2, 3, 4. So -2, -4. I want you to go through it this quick, y'all. Just getting the coordinates out. G and H. G and H, looks like that's kind of the nice little lattice point. Lattice point, by the way, is where grid marks intersect. And that lattice point looks like it's in the middle, and that'd be the point, -1, 2, 3, 4, +2. So -4, +2. And last I and J, I don't know, it looks like right here, which is the point 2, -2. Awesome. Make sure you understand those. We're just finding midpoints visually, marking down their points. Let's see if I was right. Oh, I have to exit out. You ready? You guys will be able to check me. Ooh, 3, 3, -2, 2. Ooh, that said EF is -1.5. Well, so I was a little off on that. I guess I should have checked because where I put was right here, and that would have been 1, 2, 3. 1, 2, 3, 4. Oh, yeah, it was. I didn't even look at that. Look at that. And then the rest of them are good, so I need to pay attention more on the EF. How about that? Awesome. Let's roll. Are you ready? Perpendicular bisectors. We're going to talk about some serious theorems today. There's going to be a little bit of note writing, so just keep that in mind. This is split up into 2 lessons. So, I better. Sometimes he's having a moment. The town of Fair Lake, Hartsdale, and New Holland have saved enough funds to build a new pool. A city planner has been hired to determine the location of the pool so that it is the same distance from each town, so it needs to be equidistant. Because the towns form a triangle, the perpendicular bisectors of the triangle can be used to find the best location for the pool. We're actually going to talk about that today. If you use the perpendicular bisectors of each leg of the triangle, where they meet in the middle is going to be equal distance from each of the points, which are the surrounding cities, or towns, right? Yeah, surrounding towns. So you ready? Here's how we roll. So these are each perpendicular bisectors. They're perpendicular to the leg of the triangle, and they cut that leg in half and go out to the middle, and where they meet is where that pool should be. So you can see that right there, little animation. That's really what we're going to be talking about and doing today. So buckle up, buttercups. Let's get ready for this ride. Boom. Gotta move this up. Wrong thing. Awesome. So here's where there's going to be some notes. I'll tell you what to write down and what to draw, because we're going to need these, and these are going to be things that you're going to use permanently. So here we have right here, perpendicular bisector of segments. A perpendicular bisector is a line, segment, or ray that passes through the midpoint of a segment and is perpendicular to that segment. You're going to want to write this down. So right here, go ahead and write all of this down. Then I want you to draw this right here. Like I said, there's going to be a fair bit of drawing and notes today. You'll need to pause this to do it. But draw the segment JK, and RS is a line that is a perpendicular bisector of JK. It's going to cut it right in half. That's why we have a tick mark over here and a tick mark over here showing you that they're the same length. All right, pause it if you need to, and then I'm going to move on down. Okay, and again, I'm going to have you do two things right now. I'm going to have you draw this and write it, and this as well. So we're going to do it one at a time, but just know a little bit of writing today, and then we'll get through it. So what do we need to write down? We need to write down Theorem 6.1, perpendicular bisector theorem. And you're going to write down the words. If a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints of that segment. And what is our example? Well, we look over here. We see if CD, that's that line, is a perpendicular bisector. This symbol right here means perpendicular. Okay? Is a perpendicular bisector of AB. So we have line CD, and it is a perpendicular bisector of AB. So it cuts. So we know that AD is congruent to DB. If that's true, then what do we also know? If we draw a line from A to any point on this perpendicular bisector, no matter where it's at, that point could have been up here. That could have been C point. The point could be down here. And we'll show this later. If we draw it to any point, then the line created, AC, is also going to be equidistant to BC. This is the perpendicular bisector theorem. All right, we're going to go ahead and move on down. Pause this if you need to, write it down. And this is the converse of the perpendicular bisector theorem, which means we're going to come at it backwards. So this, from this one, we're saying we know these lines are equal because they're extending from a point on the line that was cut in half to anywhere on the perpendicular bisector. But now we're going the backwards way. We're going to say, listen, and do write this down. You need to label it. What are we labeling it as? Theorem 6.2. So last one was 6.1. This is 6.2, converse of the perpendicular bisector. If a point is equidistant from the endpoints of a segment, then it is on the perpendicular bisector of the segment. So this one we're coming backwards. We're saying, hey, if this right here, if a point is equidistant from the endpoints of a segment, so this point E is the same distance from A as it is from B. And if that's true, then we can say that DE or EC or whatever you want to call this line must be a perpendicular bisector of AB. So what is it saying here? If AE equals BE, so these two lengths equal each other, then E, right here, that point, lies on CD, this line, this whole line, the perpendicular bisector of AB. I know this stuff is really technical. We'll get through it. We're going to use it. So again, draw this, write down the words, write down the example. We're going to work some things out coming up. Okay, use the perpendicular bisector theorem, and we need to find QT. So what are we trying to find right here? We're trying to find QT. Let me go ahead and highlight QT. We're trying to find what this is, QT. Okay, what do I know? I'm told that QR, because of these tick marks, I know that QR is equal to SR. And what does the perpendicular bisector theorem tell me? Well, because these two have been cut in half, we know that RT is a perpendicular bisector. And if it's a perpendicular bisector, what else do I know? I also know that the distance from Q to T is the same as the distance from S to T. So I can set these two I've highlighted in yellow equal to each other. So now I go, all right, well then 7x minus 3 equals 4x plus 9. Boom. And we're going to solve that, right? Subtract 4x from both sides. And y'all are pretty advanced, so I'm going to go, in the same breath, I'm going to add 3 to both sides, right? I'm moving the x's left. I'm moving the numbers right. 7x minus 4x is 3x. Negative 3 plus 3 is gone. 4x minus 4x is gone. I'm left with equals 12. And when I divide everything by 3, boom! I get that x equals 4. And I need to find QT. So I'm going to plug that 4 back into here. Remember, I know we're tempted to put 4 as the answer, but it's not. That's the answer for x. We want to find the distance QT, so I'm going to plug it back in. All right? So I know that QT equals 7 times 4 minus 3. Well, 7 times 4, that's 28. What's 28 minus 3? Boom! 25. Is there 25? D is 25, so this is the actual answer right here. Make sure you always read these to know what you're looking for. And we can confirm that by going, boom, look at that, it was right. I'm going to reset the activities on this page. That way when I present this in class, it's not all messed up. Okay, let's go to the next slide. This will be, I believe, where we're going to end it for today. Yeah. And we'll come back tomorrow and do a little more. We'll release you all to do some on your homework. Your homework's going to cover both days, but this will give you an option to be able to do at least a significant portion of the homework. All right, let's look at this. It says, because, now I'm going to get my writing utensils out so I can mark this up. You're going to want to draw this in your notes. And after you draw it in your notes, let's mark up. Because Wx equals Wz. We know that Wx equals Wz. Boom. When we see that, it's 25.3 equals 25.3. And line WY is perpendicular to line XZ. So WY is perpendicular to XZ, which we see that because we have the 90-degree angle. That perpendicular just means 90 degrees. By the WY is the perpendicular bisector of XZ by the converse of the perpendicular bisector theorem. Therefore, XY, so we know that XY then must equal ZY. By the definition of the segment bisector. XY then must equal what? XY must equal 22.4. Because ZY equals 22.4. So see how we went backwards? Since we know this distance from WX is the same as WZ, since that's true, we're told by the converse of the perpendicular bisector theorem that this point W must lie on the perpendicular bisector of XZ because it's equidistant from both X and equidistant from Z. Therefore, because it's a perpendicular bisector, by definition of a bisector, it bisects XZ in half, which tells us that ZY and XY are the same. So then we can label this as 22.4 because we know they're the same distance. Whoa, good stuff. Go ahead and start today's homework. There's going to be problems that you may not be able to do. Just skip them and move on to the next ones. And tomorrow we'll finish with the lesson. You should be able to go back and fill in any missing homework problems you weren't able to finish. With that said, peace out.